reflections. Unit 6A is all about transformations, and we're going to look at them individually in 6.1, 6.2, 6.3. And then when we get back from break, we're going to start combining them. So reflections, we are going to focus on 4 different types of reflection that you need to be able to do over the x-axis, the y-axis, the line y equals x, and the line y equals negative x. So we're going to start with point A, which is at 5.1. So here's my original point A, my pre-image. Okay, and they want us to perform the following reflections. Okay, so graphically, if you're reflecting, a reflection is just a flip. Okay, you can see it's got that word or those letters FL in it. So here, I highlight for you what I'm talking about. See FL, a little thick. Right there, FL, and think of that as standing for flip. Okay, so when we reflect something, we are flipping it. Okay, you look at your reflection every day in a mirror. A reflection is a mirror image. Okay, so with just an ordered pair, that's not really important that it's a mirror image because it's just a single point. But when we start reflecting images, like a polygon or triangle or something, then you'll see more. Because like when you look in the mirror, you know, you raise your right hand. In the mirror, it looks like you're raising your left hand because it's reversed, because it's flipped. Okay, so to reflect across the x-axis first, I'm just going to highlight, you don't have to do this, but this is the x-axis. Okay, so we're reflecting it over the x-axis. So that means horizontally, it's not going to change. It's not going to go left or right any. We just want to come straight across the x-axis. So however far you are from the x-axis, that's how far away you will be on the other side. So we're 1 above, this would be 1 below. So the reflection across the x-axis, and it says to label it point B, would be here. So notice that would also be x value of 5, but now it would be -1 instead of 1. So what's happening when you flip across the x-axis, you take your xy value, x stays the same, and notice the y went from 1 to -1. So you are changing the sign of y. So that's the rule or the formula for reflecting across the x-axis. And now if we reflect across the y-axis, the same concept. Here's our y-axis. But instead of going up or down, we're going to go left or right because we have to cross the y-axis. That's what we have to do. So point A is 5 units to the right of the y-axis. So a reflection over this would be 5 units to the left, but at the same height. It would be here. And it says to label that point C. Okay, so that is at -5, +1. So you'll notice from our original point A, what happened to our xy is the x went from 5 to -5. So the x changed signs, but 1 and 1, the y stayed the same. The y did not change. Okay, so when you're reflecting across the x-axis, x doesn't change. When you're reflecting across the y-axis, y doesn't change. Now, besides reflecting over the axes, we also want to be able to reflect across the lines y equals x or y equals -x. And this is the line y equals x is just a linear equation with a slope of 1 that goes through the origin. So this is the line y equals x. So if I'm going to reflect across that line, this one's a little tougher because you can't just count left, right, or up, down. We're actually going to have to count both. So A, for instance, now if it is at a perfect diagonal like this, you could count it this way. If you'll notice, I go at an angle 1, 2 diagonally, 2 diagonal squares. Okay, and that gets me to this line. And so if I went 2 diagonal squares here, that would also get me equidistant on the other side. Okay, think of these lines that we're reflecting across. They're your line of symmetry or line of reflection. If you were to fold it along that line, the points would match up. So I'm going to label that as point D. So if I were to fold this over this green dashed line, D and A would touch. If I were to fold across this red, along this red line, A and B would touch. If I were to fold along this blue line, C and A would touch. Okay, so that line of reflection or line of symmetry. Now, notice that ordered pair for point D is at 1, 5. So how does that compare to your original point, 5, 1? They switched spots, your X and Y values. So the rule, the way you would write the formula or the equation for this would be you just simply switch your Y and your X. Nothing changes sign, you just switch them. You're going to talk more about this when we do inverses in Algebra 2. I don't know if y'all touched on inverses in Algebra 1, but inverses, it's when you switch X and Y, are reflections across the line Y equals X. And then last but not least, the line Y equals negative X. So that is a diagonal line again with a slope of 1, or excuse me, negative 1 this time. It goes through the origin. So here is the line Y equals negative X. So I'm going to go back to my original point A here, the black one, and I want to reflect across this purple line. So 1, 2, 3, 1, 2, 3 at the angle would put me here. I'm going to label that as point E. Notice if I connected these that I'm reflecting across, any of these colors, if I connect them with a line, that line is perpendicular to the line of symmetry. If I connect A and E, it's going to be perpendicular to this purple dashed line. If I connect A and B, it's going to be perpendicular to the x-axis. Okay, so that when you connect the reflected points, they should be perpendicular to the line you're reflecting across. And then here, point E is at -1, -5. And if we compare that to the original point, you can see not only did the X and Y switch order, they also both changed signs. So I would say this becomes -Y, -X. So you switch the order and change the sign. So these are the different rules for whichever line you're reflecting across. Okay, so we're going to try this. We're going to apply these rules in these examples. It says with images, not just a single point now. Reflect the triangle below over each of the following lines. Label the images A prime, B prime, C prime. Because remember, we talked about when we did dilations, we talked about how you have your pre-image and then your image after the dilation or after any transformation. You're going to use those same letters, but you're going to put that little apostrophe, and that means prime. Okay, so this one is over the x-axis. So I'm going to just highlight that or outline that in red. So you can see this is what our line of reflection is. So if I flip this image, some of you, it's easier to do this graphically and just to say, well, B is on the x-axis. So if I go over the x-axis, that's not moving. C is 2 below, so it should be 2 above. A is 3 below, so it should be 3 above. So here is my image given that pre-image. It's supposed to be red. And you can see if I were to fold along this line, all of those points would align. So I just need to label those now. This would be C prime, A prime, and this is B and B prime. They're the same. Now it doesn't ask you to list the points, but if you did, I want you to notice B was at 3, 0. if the rule says, okay, leave X the same and just change the sign of Y, X stays 3, 0 doesn't have a sign. That's why 0 stayed 0. That's why B didn't change, because it was on the line of reflection. C was at 4, -2. So 4 stayed the same, but my -2 became +2 because I did the opposite. So C prime is at 4, +2. So you can see, if you prefer to use this rule, you can use the rule. If you prefer to just flip it, if that makes more sense to you, do it that way. That's fine. So for B, we're reflecting across the y-axis. Here's our y-axis. So I'm going to start with A. It is 1 to the right, so it's going to be 1 to the left. So there's going to be my A prime. C is 4 to the right, so it's going to be 4 to the left. There's my C prime. B is 3 to the right, so it's going to be 3 to the left. There's my B prime. And again, you could check those ordered pairs and confirm that that rule that we wrote was used. And if I folded this, and you can visualize folding it along this line of reflection, these would match up, they would meet. It's a mirror image. All right, and then C is across the line y equals x, so that's this diagonal we want to reflect across. Now, reflecting over y equals x and y equals -x is tougher for some people because you're not counting just perfectly straight. It's at a diagonal. And so if you don't like doing that, just use the rule up here. So you could simply just take your x, y. So let's start with point A. A is at 1, -3. So the rule says, okay, switch the order. So instead of 1, -3, it's going to be -3, 1. So that's my new A prime. Okay, B is at 3, 0. If I flip that, it should be at 0, 3. So there's my new B prime. And then C is at 4, -2. If I flip that, it would be -2, 4. So there's my new C prime. So you can use the rule like that to plot your points if you prefer. And again, I think y'all can visually see, if I were to fold it over this line, these would match up. In this example, they want us to draw a triangle PRL. P is at 4, -1. R is at 5, 0. And L is at -2, 3. All right, so I'm going to draw this triangle. This is my pre-image, PRL. Now draw the image P prime, R prime, L prime after a reflection of PRL over the line y equals -x. So again, y equals -x. It's the -1 slope through the origin. So I want to reflect across this line. Now this one actually does ask for the coordinates. So sometimes they already have the pre-image listed out. If they didn't, if it was graphed, I would list them out. Okay, so the rule for reflecting across y equals -x, you can go back up here at the top, says you're going to switch the order and change both signs. So for P prime, 4, -1 is going to switch. The 1's going to come in front, but it's going to change to positive, and the 4 is going to go second, and it's going to become negative. So 1, -4 is P prime. I probably should have labeled the original P, R, and L. Okay, now R prime, I'm going to take my 5, 0, I'm going to switch it and change the sign. 0 doesn't have a sign, so it's going to stay as 0. The 5 will become -5. So 0, -5. It's my R prime. And then L, I'm going to switch the 2 and the 3. The 3 is going to become negative. The 2 is going to go to positive because you're doing the opposite of both. So that's going to be -3, +2. And you can see your L prime. And again, some of you could have done that just graphically without using the rule, but they did ask for the coordinates. So in my opinion, when they ask for the coordinates, it's easier to just use the rule. Okay. All right, now this says, what about reflecting a line? Okay, so if we're reflecting a line, it's a little different. So we want to first graph the actual line. Y equals 2x plus 5. Okay, it says, what are two original points on this line so that we can graph it? Okay, so if it's in y equals mx plus b form like this, oops, that's a line, not a pen. You can identify the y-intercept is at 5, so there's a point at 0, 5. And then you can pick any other point you want. You could plug in a 1 and see what that gets you. If I plug in a 1, 1 times 2 is 2, that's going to be 7. So there's a point at 1, 7. Okay. Or you could use your slope of 2 and count from there. But we start at 0, 1, 2, 3, 4, 5. And then 1, 7. So there's 2 points on the line. So this is part of the line that I'm trying to reflect. Okay. And if you chose other points, that's fine too. You can see that it's got a slope of 2. So if you want to plot more, like you could extend this line. You could have used any of these. It doesn't matter. Just pick 2 points that are on that line. Okay, now you're going to reflect those points. This time we are reflecting it across the, what's it say, x-axis. So we're going to reflect across x-axis, which is this. So I just take 2 or 3 or 4, however many points you ended up plotting, take those and reflect them. So this point here that I ended up with at the bottom was at -2, 1. So it'll be at -2, -1. This point is 3 above, it'll be 3 below. And notice I said this has a +2 slope. So now this has a -2 slope. So you could just keep going that way. And you can see that line. So I'm going to actually graph the whole line now. So there's the original line. And here is the reflected line. And you can see anytime you reflect a line over something, that the original, the pre-image, and the image should intersect on the line of reflection, no matter what that line of reflection is. The point of intersection of the two lines will be on the line of symmetry or the line of reflection. So then we did step 2, which was reflect the points. Now it asks, what's the equation of the new line? So we can see, okay, for the new line, we have a y-intercept here. We said that there's a slope of -2. And this y-intercept is at -5. So y equals mx plus b. That would be the equation of this new line, the image. Now, if you didn't see the y-intercept when you redrew it, you could use the 2 points that you reflected here, because remember that we would apply the rule. So the rule using those 2 original points I wrote says that x stays the same, y changes sign. So you could just pick 2 points like this, and you could use point y minus y1 equals m times x minus x1. You could plug in your xy for one of the points and x1, y1 for the other point and find your slope if you couldn't count the slope. Or if you should be able to count the slope. You could plug in the slope and either of the 2 points in for x1, y1, and you could work this to get it in y equals. So that's another option if it's not clear what the y-intercept is, if you don't have an actual point plotted there. All right, so let's try one more like that. So the line is going to be reflected over the y-axis. So this is my line of reflection. Okay, so this is 4x plus 1. So the slope is 4, the y-intercept is 1. So I know I have a point at 0, 1. And then a slope of 4. It's 4 over 1. So there's a point at 1, 5. Or I could have plugged in any x I wanted and calculated to get a second point. Okay, so I've got 2 points. That's really all I need. If I apply the rule of reflecting over the y-axis where x changes sign, but y stays the same, I end up with this. And the reason the first point didn't change is because x can't change sign when it's 0. 0 doesn't have a sign. So I would plot these new points. This is going to stay the same, but I'm going to go -1, 5. So here is the original line. And here is the reflection of that line. And you could extend it in both directions if you wanted to. You wanted to draw that up further and put arrows on it because it's a linear equation. That's cool. We can do that. So black is the original, the pre-image, and blue is the image after the reflection. Then they want the equation of that line. So it's got a y-intercept still at 1, so b is still 1, and now my slope is -5. So if my slope is -5, my y-intercept is 1, my equation would be -5x plus 1. Or actually, 1, 2, 3, that's 4, not 5, that's my bad. I miscounted there. That slope is -4. Okay, so that's reflecting a line. So reflecting points, reflecting images, and reflecting lines. Stop this video.